And a lot of this is review stuff that we talked about earlier. But before, I never actually expected you to sketch it, and now we are. We're going to sketch the whole thing. So how do you think we're going to start this? Bailey? Yep, we're going to factor it. And when we factor it, what do you notice? Something cancels. And when something cancels, what does that mean? We're going to have a hole. And that hole is going to be where? Where x equals -1. Because that's the factor that canceled out. Now, how do I get the y?
Plug in.
Plug it in right here. So that would be what is that? 2 times -2. Is that 4/5? So I'm going to plot my hole at -1, 4/5. Okay. What else can you tell about, here's our equation now. That's our reduced equation. What else can you tell about it?
Horizontal asymptote.
Where is the horizontal asymptote?
You get it from the top, right?
You get it from either place. Horizontals can come from either place.
Oh, is it just x equals 2? Or y equals 2?
Y equals 2.
Y equals 2.
Our horizontal asymptote is y equals 2. Can someone explain that?
It's the coefficient from the top line.
Remember this whole thing, guys?
The degree.
Gotta dig back in your memory now. We talked about all that. That's your horizontal asymptote. Here, it would be 2x over x. It would be the same thing. It doesn't matter where you get it. All right, so that's my horizontal asymptote. All right, what else can we tell from this? Bailey?
The vertical asymptote
Is where?
x equals 4.
X equals 4. Because, Bailey, where do we get vertical asymptotes?
Where the denominator being 0.
Where the denominator can't be 0. All right, well, look at your list. What else do we need to find that we don't have up there yet? Look at the list down here at the bottom. What have we not filled in? What have you not filled in yet?
Y-intercept.
Y-intercept. All right, what's your y-intercept? How do you find a y-intercept?
X is 0.
Let x be 0. So if we let x be 0, what will we have? On top, we'll have -2, and on the bottom, we'll have -4. So 1/2? All right, what are we still missing? One more thing. And what are zeros? Zeros are another name for roots. What else? X-intercepts. Zeros are your x-intercepts. And how do we find those?
Equalizer.
We let y be 0. So we solve that equation. I'll let you solve it, because I don't want you just copying mine down. For some reason, some of you have a hard time with this, so do that. Solve that equation. Matt?
I was in extended time on Wednesday, so I didn't get one of those packets.
I did. Did I just hand these out that day? I thought I handed these out before. Well, I don't know. I thought I handed them out a long time ago. Maybe I didn't. And I don't know.
Never mind, I got it. Last Housekeep told me that they passed it out.
Yeah, I thought I handed them out before that, another day. So you've got it somewhere. All right, have you figured this out? X equals 1. I'll go through this one time. I'm not going to do this anymore. You guys need to be able to solve this equation. Multiply your denominator over here, it's still 0. Divide by 2, it's still 0. Add 1, x equals 1. Now, connect the dots. Do you have a good idea of what's going on over here? Do you have enough information to kind of see that that's what's happening over here? Remember, the curve is going to approach its asymptote. So when you connect these 3 dots that you've got right here, when you connect them, you just kind of keep going. How do I know that this doesn't turn around and come down? Well, you can have, some of these will have parabola-like shapes in them, but how do I know that absolutely cannot happen?
It's going towards the asymptote.
Well, it has to approach its asymptote, and it can't cross the axis anywhere but there. And you're right, Hannah, it has to approach its asymptote as it goes all the way off the page. That's only half the picture. Tell me about the other half.
On the other side.
It's going to be up here. Now, I know that for a couple of reasons. First of all, I've done about a zillion of these in my lifetime. Second of all, I know, like Hannah, that it has to approach its asymptotes. So my choices are these. It's either up there or it's down here. How do I know it's not down here? It can't cross the axis anywhere but where I plot it. If that is at all confusing to you, you are simply going to plot some extra points. So this is 4, you're going to put in 5, you're going to put in 6, you're going to put in 7, and you're going to plot as much as it takes for you to figure out if that's what that curve looks like. Now we're going to answer some questions about it. Erase all this. I'm going to use my graph to answer some questions. And this is our limit notation. We talked about it before. This says the limit as x approaches infinity of this function. That's our function. So the limit as x approaches infinity and negative infinity. This means the limit as x approaches 4 from the negative side. So here's 4. The curve can approach from the negative side or from the positive side. That's left and right. And the same thing, we can approach -1 from the positive side, or we can approach -1 from the negative side. So you can think of these as like right and left. The negative side and the positive side. Okay, I'll number them. And you tell me if you figured any of these out. What do you think? Anybody got an answer to any of those? Trevor, what's on your iPad?
The bridge.
No one has any idea about any of them? X approaches infinity. Where is x approaching infinity? Clear over there, right? Tell me what the function's doing. What is your curve doing as you go off the page that way? This says x goes to infinity. That's that way. Tell me what the curve is doing. As you draw that picture and you head off the page on the right side, what is the curve doing?
You're getting the negative. Ooh.
What's it doing? It's not going like this.
It's going negative, isn't it?
No.
Going down.
It's going down, but it's not going down forever. What's it going toward?
Asymptote.
What is my hand doing? Getting closer and closer to,
0.
not 0,
The asymptote.
getting closer and closer to
2.
2. So the limit as x goes to positive infinity is 2. And I'm going to put a little plus up there, because when I am getting closer and closer to 2, there's 2 ways I can do that. I can get closer and closer to 2 from the top, or I can get closer and closer to 2 from the bottom, right? And if all you said was 2, somebody who didn't have the picture wouldn't know what you meant. Now we know exactly what's happening. We're getting closer to 2 from the top. All right, what about this one? What's this say? As x approaches negative infinity. Where's that? That's out here, right? So draw your curve. Go this way. What's happening to your pencil?
It's getting closer to 2.
It's getting closer to 2 from the bottom. Right, now what does this say? Here's 4. What am I doing? I'm coming from the negative side. So here we go. Coming from the negative side, what's your pencil doing? As you get closer to 4, what's your pencil doing? Going to negative infinity. It's going straight down off the page. All the way. Nothing stopping it. Just go, 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 go. What about from the other side? What's happening to the curve as you get closer to 4 from the positive side?
Going to infinity.
It's going to positive infinity. All right, now, -1. -1's right here. This says, let's come at -1 from the positive side. So what's happening to my pencil?
Stop it.
It's stopping. Where's it stopping?
At the whole of negative
Right,
1.5.
which is what Y value? How high is it?
4/5.
So that's 4/5. Limits are Y values. What's happening to Y? This tells you what you're doing with X. You're trying to figure out what you do with Y. So now we're gonna head toward this point from the left side, from the negative side. Here we go. What happens?
Stops.
Where does it stop?
4/5.
4/5. Don't those come to the same place, whether you're coming from the left or the right, don't you come to the same place? All right, turn that paper over. Take a minute and see if you can answer that top question there. 1, 2, and 3. Questions, but here are the first couple. Got an answer to this one?
Infinity.
Number 1. Got an answer to this?
Infinity.
Constant infinity? Let's see, is that right? We're approaching 2 from the negative side. We're coming in from the left. Here's 2. We're coming in from the left. What's our curve doing? Up, up, up. That's exactly right. How about this one? What'd you get for this one? You said negative infinity? Check it out. Here's negative 1. We're coming from the positive side. As we come from the positive side, what's our curve doing? The closer we get to negative 1, the farther down we're going. That's exactly right. How about this one? This is a new one I put up there. That was on the paper. What about this one? Where's X approaching infinity? What are we doing? 2 from the top? How about this one? 2 from the top? How about this one? where x is 0, right? Where x is 0. What happens as I come at that from the positive side, from the right side? What's happening?
It's lower.
I get to a point, right? I stop. Where do I stop?
Like 1.
Would it matter in that case if I was coming from the positive or the negative? In other words, what would it be if I came from the negative side? It'd still be 1, because you're stopping at that point, right? And what's the domain? Could you answer that question? X can't equal -1, and x cannot equal 2. -1 or 2. X cannot equal either one of those. So your domain is everything except -1 and 2. And why can't x be -1 or 2? Because you have asymptotes there. Okay, take a minute, look at the bottom of that page. That's a much easier function than the one we sketched earlier. Here's what I want you to do. Now, I don't know if there's room on the page or not, but I want you to fill in the blanks and then also draw a little sketch of it. So right now, fill in the blanks, draw a little sketch of that thing. You may have to do that on a separate sheet of paper. Anybody got a picture going yet? to have a volunteer put this up. Okay, you don't have to answer all the questions up here, but is there anybody that can get it drawn? What do you think, guys? I think it looks pretty good. Anybody have a question about it? One picky little quibble. That dot right there, that should probably be moved up a little bit because 6/5 is 1 1/5, right? So that's down a little bit too low, but picky. Everything else looks great. Would you agree? All right, let's start filling these in now. Number 1 up here. Once you have your picture, these are easy. What's the answer to number 1? 3 from the bottom. It's coming toward 3, but it's coming from the bottom. This means as X goes off the page, what is your pencil doing? It is getting closer and closer to 3 from underneath. All right, what about the other one? Second one. It's over here. She's kind of got it pointing up. She didn't mean that. It's getting closer and closer to that asymptote. So it's approaching 3 from the positive, from the top. -5, that's your vertical asymptote. We're approaching 5 from the right. What happens to your pencil as you get closer to my arm from the right side? It's going down. What's happening as you approach my arm from the left? Everybody okay with that? All right, you go ahead and get started on your homework. Little heads up. Looks like our next test will be the end of next week. There's only 3 sections to cover. In this section, we've already did most of it earlier in the year.